Hi, welcome to Open House. My name is Mr. Town. I'm going to talk a little bit about myself and about my physics classes, and I'm going to talk a little bit about what we learn about in physics. So I teach AP Physics 1, AP Physics 2, and Physics of the Universe. I am a family man, and I have been married for 30 years, and that's my lovely wife. I've got 2 grown sons. Aren't they handsome? And my career has been as an engineer and as a high school science teacher. I became a grandfather for the first time in May, and that is my little baby Archie. That's my older son and his wife. And here's Archie. When I'm not teaching, my favorite thing to do is to get out in the wilderness, to explore, camp, hike, and I just love it. I just love the outdoors. I love being away from civilization for a little while. It kind of feeds my soul. My career has been as an engineer for more than 20 years, and my degrees are in engineering, and then I became a teacher. Back in 2005, I did my student teaching at Anaheim, and I got hired on, and I've been teaching there ever since. I like to say that I liked being an engineer, but I love being a teacher. These photos are from when I was the coach of the robotics team at Anaheim High School. My physics class is about the real world. I love bringing to my students real-life demonstrations and experiments, like this video I did of launching an air-powered rocket at the park near where I live. And here it goes. Sometimes I make video demonstrations to show my students. This is a typical type of demonstration I did in my backyard, having to do with the laws of motion. I give some of my instruction in class by video, and here is a video of me
this is how you
teaching them how to do a pendulum experiment.
In this example, I'm going to have 2 racers.
Here are some more example videos. These are videos that I did for the students as demonstrations. So I often give instruction using videos.
Alright, this is what you want to do with the paperclip. You're turning it into a space.
And the students themselves make videos. So here are a couple videos. This is a chain reaction.
Okay, Mr. I got 38 books here.
I love the way this student got her little sister to help her. It's awesome. My students do a lot of labs. So because it's online, they are virtual labs most of the time. And but there's a lot out there. There's PhET simulations and gizmos, and we use them a lot. My students also learn how to do calculations, and that's part of physics. My students also do a lot of writing. They do journaling, they summarize, and they practice using their academic vocabulary. We do group activities. In Schoology, we can have breakout rooms, and the students, 3 to 5 of them, they have some common goal they're trying to achieve. They talk to each other, and they work together to achieve the assignment. Also, my students draw. That's part of physics, is drawing. So it's part of their homework. We do it in class, lots of drawing. And my students make videos. These are videos all made by students as part of an assignment on motion. Physics of the Universe has 6 instructional segments, one of which is energy. Energy is a central idea in physics, and our students learn what is energy, what are the different forms of energy, how is energy transferred from one thing to another, how it changes form from one type of energy to another, and what conservation of energy is. We also learn about what are our sources of energy and what are the relationships between energy and climate change. Thank you for coming to Open House and letting us share with you some things about our science program here at Anaheim High School.
Hello everybody! Welcome to Open House. My name is Bill Johnson and I'm one of the Physics of the Universe teachers here at Anaheim High School. So just a little bit about myself. I've been teaching physics for a few years now. Before that I taught chemistry and I've taught a few math classes in my day as well. I'm really loving our experience this year. It's obviously very different than the regular school year, but I think we've found ways to kind of connect and make the best of it, and I hope you can kind of see some of that in this presentation. Just kind of a quick overview of my class. I like to focus on a lot of things that bring some relevance and human experience to our physics classroom. I like to bring in stories about the scientists and their experiences. I like to challenge our students by having them read articles and stories that maybe they wouldn't read in a traditional physics class, but that have to do with the science. Stories that inspired scientists, stories of science in conflict with other scientists or with society or cultures, and I have the students talk about them and write about them and do all kinds of things like that. So I hope your students are enjoying their time in our class this year. But let's just kind of talk about what this classroom looks like this year. So let's go back in time, way back in time to the year 2019-2020, and this was my physics class. It still is my physics class. It's still there over at Anaheim. But these are my students from last year, and they're working on things in the classroom, and you can see them working on group projects together. You know, they're still working on some Chromebooks. We had some simulations there and things like that, working out, various real-world examples of forces and building things, right? We engineered a lot of things in that class, and you can see the kinds of things that we were able to do in that in-person instruction. And here's a couple of videos, right? Just kind of, I don't know, an average day in my class over at Anaheim High School. Well, things changed in the year 2020, right? The first thing I had to figure out was how was I going to build that classroom culture online? And so I began by a series of activities that really didn't even have anything to do with physics, but were more about community building, right? So you saw some poems and you saw some discussions and some pixel drawings, and here's one of our discussion boards on scientists in Hawaii, and we basically brought that learning community online by trying to do these collaborative projects together, having these discussions together, and finding a way to kind of put our voices together. One of the ways I did it this year was through reading clubs. So here were some reading club topics, and I had students read these short stories and articles and ultimately create these found poems about physics, right? So they're bringing in that creative element and working together. But we also found time for the engineering projects, right? So here we have that classic egg drop experiment. I had students design and build out all the different parts of the egg drop experience. Being online gave me a lot of opportunities to try out different tools and different methods of instruction, but one thing I did not realize was how many costume changes I was going to have to do this year. Enter. Hello, I'm sorry to disturb you, Captain. Oh, hello. You must be the new engineering officer. I'm the chief engineer down here on the Ting Tonk. Well, hello there. Oh, hello. I didn't see you there. I'm the chief tactical officer, and I'm here to teach you all about torpedoes and shields and all the things that we do in tactics. Admiral Hackbar, I should have known it was you. Do you think that I forget our battle on Rigel 12? The fourth instructional unit for Physics of the Universe is Nuclear Processes, and during this unit we talk about all sorts of things that are really, really fascinating, from the Manhattan Project and nuclear bombs, radioactive decay and half-life, how particles break down, chain reactions, and all kinds of things that have to do with nuclear power. We explore areas like Chernobyl, we look at things like fusion and fission, and we have students discuss all the different ethical and moral ramifications of these scientific technologies. It's a very interesting unit that I find a lot of students enjoy and really take with them as they move forward in physics. Overall, I would say it's been a really great year in Physics of the Universe, and I know that this is a non-traditional way to learn, but I feel like our students are stepping up to the challenge and really exploring all the technological avenues that this style of learning has to offer. So I really look forward to the next 4 months. I hope that we can cover a lot of the fun topics that are coming to us in physics, and I look forward to ending the year strong. Thank you for being part of my learning community today.
Hi everyone, my name is Miss White, and I am a student teacher for Mr. Johnson. So as a student teacher, I observe his classroom, I come up with my own ideas for the classroom, and we incorporate them together. As a student teacher, I have received a bachelor's, and I received my bachelor's in physics at Cal State Fullerton in 2019. And currently I'm working on my master's in physics, and I'm also working on the credential, right? So I want to get a credential in teaching and go into teaching high school. I'm doing both of these programs at Cal State Fullerton. So a little bit about myself. You have seen a guest appearance. This is Kurt. He's one of my 2 cats. My cats are still pretty young, under the age of 1 year old, so they make a lot of appearances. They cause a lot of trouble. Everyone sees him in class either every day or every other day. He hangs around a lot. Other than that, I coach softball in my free time. I actually coach at Savannah High School, and I've been doing that for the past 4 years or so. I used to play softball for 13 years. I was going to play in college, but it turned out that education and learning physics took a lot more work. And so softball became a back burner, but I enjoy coaching. I coach generally junior varsity, but I also am the pitching coach for varsity. So I have a lot of fun with that. So that's a little bit about me. Let's look into what we do in the classroom. Alright, so one of the topics that we discuss in physics this semester is forces at a distance. Now what does this mean, right? Usually when you think of force, you're thinking of something pushing on another object. Well, when we look at forces at a distance, what we're actually looking at is forces that act on objects that might not be touching each other. So we have a magnetic force that we can discuss, right? When magnets get close to each other, there's that attractive force. You can feel it, right? You're trying to make it so the magnets don't come in contact with each other. Another thing that we have that is a force at a distance is the electric force. This could be things like rubbing a balloon on your hair, okay? And it makes your hair feel kind of funny, makes your head feel kind of funny. That's an electric force, right? Another force at a distance, which is one that we spend a lot of time on, is the gravitational force, something falling down due to gravity. In the first semester, we talked about Newton's laws, and Newton had this universal gravitational constant. And this is where we can use a constant to talk about gravity everywhere, right? We have gravity in space. And throughout the semester, we're going to be discussing how these forces at a distance can be used in space. We'll eventually tie it all together and discuss how certain things are made, like black holes or supernovas, right? We have to take into account these forces at a distance in order to understand these anomalies that are happening. All right, so that's a little bit about me and what we're doing this semester. This is one of the subjects that your kids are learning when they log in and see our faces. I really enjoy working with Mr. Johnson, and we hope this semester is a great one.
Hi, parents. Good evening. Welcome to Anaheim High School. We're so happy that you're here. I'm Mrs. Loper. I'm going to be presenting about physics of the universe, instructional segment number 5, which occurs more like at the end of the school year. We are going to, in this unit, cover waves and electromagnetic radiation. It's a very exciting topic, but when you look at it in the purely physics lens, kind of loses a little bit. So we wanted to show you how we've integrated with the earth sciences. Now, what are the practical uses of waves and electromagnetic radiation? Well, that's what I wanted to tell you about, is that now that we're looking at physics through the universe, we're actually able to tie it to some major phenomena that have a lot to do with California. Oh yeah, where we live. In fact, one of the major topics in our area is going to be earthquakes. Yeah, because those happen, and the big one is due to come any day now, right? So we will be studying waves in terms of earthquakes. We will be studying waves in terms of the ocean, and we will also be studying waves in terms of electromagnetic radiation, because at the end of the day, we know that information does travel on electromagnetic radiation. You know, those little boxes that we're all so addicted to. Well, how are your students going to be learning? Well, this is open house, and so I thought I'd show off some of the work that my students have been doing. And so this year, very different year to anything that anybody has ever experienced. And COVID has brought us a lot of challenges and also a lot of opportunity to learn some really great things. So I wanted to show you the process of learning as it occurs normally and some adjustments that we've done to be able to work virtually. So now this is a very messy process. It's not necessarily all going in that same order that I've listed, but the first step in the process of learning through online learning is, in fact, to introduce curiosity and develop a need to know. So one of the things that we used to be able to do in class is produce demos for the students and be able to give them hands-on capacities to try the different labs and the different ideas. Because we're virtual, it's not so easy, but you know, we make do. For example, we now have more access to videos like this one here. This is the San Francisco earthquake. Look at these buildings. Oh, can you see them all swaying? We do develop a need to know, and then that leads us directly to explore those curiosities. And so here's where some of the student products are visible from our online world. Students are going to be doing some readings. So you can see here, this student took 3 pages worth of notes when we were learning about centripetal force. And then you can see that they're going to be doing activities like jam boards and breakout rooms. And sometimes I even have students go into their house and their kitchen and find materials and put experiments together, bounce balls, all sorts of ideas. And then lastly, but not least, we do exercise virtual labs. And so what we're using is this app called Gizmos. Now, Gizmos provides us a platform that we have explored our curiosities. Another step is going to be to have our students really take all of the material that they've learned and put it all together and start building concrete ideas for themselves, because at the end of the day, they're the ones who have to carry out all this knowledge with your students. And then And the last aspect of assessments is going to be using this app called Quiz and that Quiz allows students to assess themselves as well as teachers being able to assess the students. Okay, so I want to let you know, parents, that, teaching online and learning online is not easy at all. Your students have been doing a great job coming to class every day. I tell you, I have about 95% attendance. I'm so proud of all of your students, which means you're doing a really great job. Your students are showing up, and that's because you're there. You're supporting them, and you're providing them a space for them to sit and pay attention uninterrupted and be able to do the work that we have to do. But the second thing is that I want you to know that we care about your children. We do give graces, and we hope that your students are doing well. But we do talk to them, and we try to get them engaged, and we do remind them to turn in their assignments. We do try to message you to let you know you're a student and help if there's any of that situation. Just know that we're here, and we do want your students to succeed. Well, parents, my name is Allison Loper, and I wanted to let you know that I am the daughter of immigrants, which makes me a really hard worker because, well, my parents were really hard workers. I teach physics, but I also teach chemistry. I've been teaching for 15 years, so this year I'm delving into a new topic, which is physics. But I love science, and I think that your students are able to gauge how much I love science, and they're also hopefully gaining the same love of science that I have. And at the end of the day, all I want is for your students to have a fighting chance to carry out a great career and do well in their future. Well, if you have any questions, don't hesitate to email me. Thank you very much. Have a good evening.
Hi, welcome to Physics, the next segment, which is Physics of the Universe, Stars, and the Origins of our Universe. I'm Mrs. Maselli, and I will start off with a little bit about myself. I have 3 children. They're all out of the house. One is married. She got married about 4 years ago. The other 2 are in college and currently missionaries for the church. My husband and I have been married for 29 years. I went to school at Irvine High School, just a little south of Anaheim High School. And I went to college at Brigham Young University. And while I was there, I had an opportunity to study abroad in Bolivia on the Altiplano. And I got to participate on a small scale farm project, which kind of started my love for science. I helped the people of the Altiplano dig a well so they could have safe, clean drinking water. And that kind of sparked my interest to pursue my major in the sciences and to teach. I love to go camping and hiking. I cook a lot of Italian food for my Italian husband. We both play role-playing games like Dungeons and Dragons, and online we play video games like World of Warcraft. I am a musician. I play the piano and the clarinet. I was in band. I played basketball and did some track in high school. And my boys each played soccer and water polo. So kind of do a little bit of everything. Okay, so let's get into physics. So the last segment likes to tie all of the stuff we've talked about the whole year together with space and the universe and stars. So first off, what are stars made out of? And how do we know what's in a star? And how can we test that? They're so far away. We can't just fly out there. We don't have enough fuel to get out there. So what we can do is remember our chemistry and remember that certain elements have certain colors that they give off. And once we do that, we can look at each star through a spectroscope, and each star has a unique little fingerprint. And it shows us, oh, there's some hydrogen in that star, maybe a little helium, a little sodium. And each star has a little spectrum fingerprint that we can look at and see what exactly what elements are in those stars. And what's really neat is that helps us know how large the star is, how old the star is, and where it is on its life cycle. The other thing we can do is observe our star, the sun. The sun is a star pretty close to us, 93 million miles away. So we can study properties about our sun and make correlations to other stars that are out there that are also suns, and it can give us a pretty good idea of what's going on in the universe. Another thing that's fun to talk about is how do we go from all of this energy, look at all that energy being given off by the sun, and how do we turn it into this kind of energy? So how do we turn this into electricity to run the computers and turn on our lights and charge our phones and all the things we need electricity for? So that's a fun topic that we get to talk about in physics. Not only does the sun give us energy for electricity, it gives us a lot of other types of energy as well. We can do nuclear fusion. If we can do fusion on the Earth, like what happens on the sun, we would have free electricity for millions of years. We just need to figure that out first. We also can do fission and create explosions. And right now, not only is this energy given off with this nuclear bomb, but that's also the same idea of energy within our nuclear power plants, but it's contained. If you think about it, the other energy that comes from the sun is also important. I mean, just the light coming from the sun is a type of energy we need for life on our planet. If there was no sunlight, then plants wouldn't be able to do photosynthesis. And if plants didn't do photosynthesis, they wouldn't make carbohydrates, which is food for us. And also, plants give off oxygen for us to breathe. So if there's no light, there's no plants, there's no us. So that's an important source of energy from our sun. Another one is UV light. So sometimes we think of UV light as UV radiation as a bad thing that can cause skin cancer. But small amounts of it actually kill germs. It can kill the COVID virus if we have UV lights. It can purify water and get rid of the parasites and bacteria in the water. It can also provide us with vitamin D, which is a healthy thing and our bodies can't make by themselves. So the sun can give us all kinds of stuff. So we can have long wavelengths of energy to help us with our communication. It gives us heat to keep our water liquid, so we have liquid water on our planet, and light for life. Ultraviolet for skin and health and disease killing. X-rays to look into our bones, and gamma rays to use for medicines to kill cancers in our cells. That's what radiation therapy is. So all of this radiation originates from the sun. So what happens to a star? Well, they're born and they live out their lives doing fusion and giving off energy, and then some things happen to the stars depending on their size, and we learn about what happens to a star, what's its fate, what is going to become of it. We've learned about things like black holes and pulsars and supernovas and red giants. And one of the coolest things to know, our sun is right here, and we have millions of years before anything happens to it, so don't worry. But one of the neatest things, looking at all these things that happens to stars, is stars actually recycle their matter. So once a star lives out its life, which is a very long life, billions of years, all that matter doesn't just go away. It actually compiles and it becomes a new star, a new planet over time. So maybe we could learn something from nature's cycles and we could take care of things better here on our planet. So physics covers a lot of stuff. Things are going on, right? We've got to study about famous scientists. We learn about collisions. We learn about different forces. We learn about the motions of our planet, different energies given off, sound, vibrational waves. It's crazy. There's a lot of stuff to learn for physics, but hopefully it's a fun ride and we come out a little bit smarter at the end. Thank you for your time, and always remember, physics rules. Have a good night.